Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter Thermodynamics. If you have any doubts regarding any question or if you are unable to understand any steps of the solution, then please write us in the comments section. We shall clarify them in the subsequent vi- videos. And if you feel that you have more difficulty in any of the chapters of physics, then also please mention the name of that particular chapter in the comments section so that we can give more priority on it and solve more questions on that chapter. Also, the homeworks on every chapter will be uploaded on the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here we shall start with the very first question of the chapter Thermodynamics. So it is told that the freezer in a refrigerator is located at the top section so that the entire chamber of the refrigerator is cooled quickly due to convection. So according to the rule of convection means the process of in the process of heat transfer through convection, the hot air is rarer. If the hot air is rarer, it means the density of hot air is less. The density of hot air is less, so it rises upwards, and the cold air is denser. Cold air is denser. It means the density of cold air is higher than hot air, so it will descend downwards. So hot air rises up and cold air descends downwards. So if the freezer of the refrigerator is located at the top section, then the hot air will rise up, then it will become colder, and then the colder air will come downwards, and then again the hotter air will rise upwards, and in this way, through the process of convection, the entire chamber of the refrigerator will be cooled quickly by the process of convection. So option A is the correct answer. Then it is told that a Carnot's engine takes heat from a reservoir. There is a Carnot's engine which takes heat from a reservoir which is at 627 degrees Celsius and rejects it to a sink which is at 27 degrees Celsius. Its efficiency will be. So we know that the efficiency of a Carnot's engine is given as eta is equal to 1 minus T2 by T1, where T2 is the temperature of this sink and T1 is the so here T2 is what? T2 is the absolute temperature. Absolute temperature means the temperature in the Kelvin scale, absolute temperature of the sink, and T1 is the absolute temperature of the reservoir, or you can say source. The absolute temperature of the source is T1 and absolute temperature of the sink is the T2. So therefore here T2 is how much? T2 is the is 27 degrees Celsius, but we have to convert into the Kelvin scale. So it is 27 plus 273 Kelvin, which is equal to 300 Kelvin. And T1 is the absolute temperature of the reservoir or the source. So that will be 627 plus 273. So this will be 300 plus 600, that is 900 Kelvin. So therefore the efficiency eta, that will be equal to 1 minus 300 by 900. So this will be 1 minus 1 by 3, that is equal to 2 by 3. 2 by 3, that is. So option C is the correct answer. Here in question number 3, it is told that 310 joule of heat is required to raise the temperature of 2 moles of an ideal gas at constant pressure. So 2 moles of an ideal gas, we have 2 moles of ideal gas. So 310 joule of heat should be supplied to raise the temperature from T initial is 25 degrees Celsius to T final, that is 35 degrees Celsius at constant pressure. So the pressure is constant. The amount of heat required to raise the temperature of the gas to the same range at constant volume. So we know that delta Q, that is equal to NCP delta T. When it is at when heat is supplied at constant pressure, then we should use Cp, which is the molar specific heat at constant uh, pressure. The Cp is the molar specific heat at constant pressure, and delta Q, that will be equal to NCV delta T when heat is being supplied at constant volume, where Cv is the molar specific heat at constant volume. Molar specific heat at constant volume. So now therefore this delta Q we have to find. Let it be delta Q dash, suppose. Okay. So now heat, that is 310 joule, that will be equal to NCV, that is N is 2 moles, so 2 into Cp into delta T. Delta T is the rise in temperature, which is 10 degrees Celsius, and when the rise in temperature in Celsius scale will be same as rise in temperature in Kelvin scale. So 10 degrees Celsius rise will be same as 10 Kelvin rise. So this will be Cp will be equal to, this is 310 divided by 10, so this is 231 by 2 joule per mole per Kelvin. This is Cp, and we know that Cp minus Cv, that is equal to R. So therefore Cv, I can say that is Cp minus R. So that will be Cp is 31 by 2, means it is 2 ones, the 2 5s are 10, 2 5s are 10, 15.5 minus 8.314. This is Cv. So now therefore the amount of heat required to raise the temperature of the gas through the same range at constant volume. So therefore the amount of heat required that will be equal to N, which is 2 Cv is 15.5 minus 8.3, that is approximately, that is 7.2. So approximately 7.2 into through to raise the temperature of the gas to the same range. Okay, so it means 10 degree only will be the rise. So that is 72 into 2 approximately, that is 144 joule. So option B is the correct answer. So in any of the steps of the solution you are unable to understand, then please write us in the comment section. We shall clarify them in the subsequent videos. So number 4 is a Carnot's engine operates with source. Carnot's engine operates with source at 127 degrees Celsius, and the sink is at okay, Carnot's engine operates with source at 127 degrees Celsius and sink at 27 degrees Celsius. So this is the sink and this is the source. If the source supplies 40 kilojoule of heat energy, then the work done by the engine will be how much? Okay, so we know that work done by the supplied heat. Work done by the heat supplied, it means it is the output energy divided by input energy. The energy output divided by energy input, that is equal to the efficiency of the Carnot's engine. So that is equal to 1 minus T2 by T1, where T2 is the absolute temperature of the sink, absolute temperature of the sink, and T1 is the absolute temperature of the source. So now therefore T2 will be equal to 27 plus 273, that is equal to 300 Kelvin, and T1 will be 127 plus 273, that is 300 plus 100, that is 400 Kelvin. Now therefore the work done by the engine has been asked to find. So work done divided by delta Q, which is the heat supplied, that is 40 kilojoule, that is equal to eta, which is 1 minus 300 by 400. So that is 1 minus 3 by 4, that is 1 by 4. So W is equal to 1 by 4 into 40 kilojoule, so that is 10 kilojoule. So 10 kilojoule is the amount of work done by the Carnot's engine. So option B is the correct answer. Then here it is told that an ideal gas is taken via path ABCA as shown in figure. An ideal gas is taken via path ABCA as shown in figure. The net work done in the whole cycle is. So first it starts from the point A, and there is an increase in the volume at constant pressure P1. So this is an isobaric process. Isobaric process. This is point B, and from point B to C. So this is a P versus V graph. P versus V graphs. Now this is the point C, from C to A. Here the volume is constant, so this is an isobaric process. Okay, this is 4P1. Now we know that work done now from here to here the volume is increased, so from here to here here volume decreases, so this one here the work done will be negative and this is positive work done, and here there is no work done since volume is constant. Okay, so here this part, so we have to find the area of this triangle, but we have to take the negative of that. So this will be half base into height, half into base. This is V1, this is 3V1. This is P1, this is 4P1. Now half into base. Base is 2V1 and height is 3P1. So that is 3P1V1. But we have to take the negative of that since the work done is negative. So option D is the correct answer. Actually here what is happening, that from A to B there is positive work done. There is positive work done which is equal to P1. Here the work done from A to B, if I tell WAB, that is equal to P1 into 2V1. And then from B to C, from B to C, there is negative work done. Now that will work done from B to C, that will be the area of this trapezium. So there is half into sum of parallel sides, which is P1 plus 4P1 into height. Height is 2V1. So that is 2 will cancel. So 5P1V1. So this is minus of 5P1V1 plus 2P1V1. So the net work done will be minus 3P1V1. Okay. Then here it is told, in which of the processes does the internal energy of the system remain constant? Now internal energy should remain constant. We know that when the temperature is constant, we know that the change in internal energy, which is delta U, that is equal to NCV delta T. NCV delta T. If it is an ideal gas. So therefore the internal energy, the rule is that the internal energy remains constant if it is an isothermal process. If it is an isothermal process, since why here the temperature remains constant, here the temperature is constant, so the U, which is the internal energy, that is also remains constant. So option B is the correct answer. Then it is told, which of the following is not a thermodynamic coordinate? So now we know that the ideal gas constant, which is R is a constant. It is a universal constant. It is also called, it is an ideal gas constant, whose value will not change for any ideal gas. So it is not a thermodynamic coordinate. So option A is the correct answer. But here pressure or volume or the temperature of an ideal gas can change, so they are not constant, so they can be treated as thermodynamic coordinates. Then it is told, a graph of pressure versus volume for an ideal gas for different processes is as shown. In the graph, curve OC represents, this is P, this is V, this is D, this is O, this is A. Now this is B, this is C. The graph OC represents the graph of pressure versus volume for an ideal gas for different processes. In the graph, curve OC represents. So now here we know that OA, it is an, here pressure remains constant, so it is an isobaric process, and OB is isothermal process. Since why it is PV equal to constant, means P is inversely proportional to V, but OC is adiabatic process. OB is adiabatic, since why here it is P is proportional to 1 by V raised to gamma. So it means that the curve will be, so the curvature of this graph would be higher than that of the isothermal process, and OD is obviously isochoric process, so it means that OC is adiabatic process. So option D is the correct answer. Since for adiabatic process PV power gamma, that is equal to constant, and obviously gamma is more than 1, since why gamma is equal to 1 plus 2 by F, so it is obviously more than 1. So P is inversely proportional to 1 by V power gamma for adiabatic process. So the curvature of the graph for adiabatic process is slightly higher than the curvature of the graph of isothermal process, and it is told the efficiency of Carnot's heat engine is 0.5. So when the temperature of the source is T1 and temperature of the sink is T2. So here temperature of source is T1 and temperature of sink, that is T2, and it is told that the efficiency eta of the Carnot's engine, which is 1 minus T2 by T1, that is equal to 0.5. The efficiency of another Carnot's heat engine is also 0.5. The temperature of source and sink of the second engine are respectively. So now it means that T2 by T1, that should be also equal to 1 minus 0.5, which will be 0.5. It means that T2 by T1, that should be equal to half. It means T2 should be equal to half of T1. It means that the temperature of the sink should be half of the temperature of the source. Now therefore now if the temperatures are 2T2 and 2T1 and 2T2, then we would get, so 2T2 by 2T1, that would be also equal to T2 by T1, which will be equal to half. So the answer is option A. Since why in option A only the ratio is coming same as T2 by T1, but in option B it will come T2 by 2 by 2T1, that is obviously T2 by 4T1. So we won't get T2 by T1 here. And in C and D also obviously we will not get the ratio as T2 by T1. So only option A is the correct answer. So then in question number 10 it is told, so in any of the steps of the solution, if you are unable to understand, then please write us in the comments section. Or if you feel any other chapter you are having difficulty, then also write the name of that chapter in the comments section. 1 mole of an ideal gas is taken from A to B. So this is V, this is T. So it is a V versus T graph for an ideal gas, and we have 1 mole of the ideal gas, and it is taken from the point A to B. It is taken from A to B, from B to C, and then again back to A, from C to A again. The variation of its volume with temperature, for that change is as shown. Its pressure at A, the pressure at A is P naught. The pressure at A is P naught. Volume is V naught. So here the volume is V naught obviously. Then the internal energy at A is more than B, at C is less than that at A, at B. Okay. So we have to compare the internal energies at the points A, B and C. So this is P naught, V naught. So at the point A and B, the temperature is same. That is, suppose this is T1, and the temperature at C, that is T2. So the internal energy at A and B are equal, since why they are at the same, since both points are at the same temperature. Both points are at the same temperature. So I will tell that since at the points A and B, the temperature is same. The absolute temperature is the same. So the internal energy at the point A, that is equal to the internal energy at the point B. So at points A and B, internal energies are equal. So option D is the correct answer. Then in question number 11 is told that for which combination of working temperatures, for which combination of working temperatures of source and sink, the efficiency of Carnot heat engine is maximum. Okay, so it means that the efficiency of Carnot heat engine is 1 minus the temperature of sink by temperature of source. So it means that efficiency eta is maximum. Eta is maximum if the ratio of the temperature of sink and temperature of source is the least. So this ratio of temperature of sink and source is minimum. So if this ratio is minimum, then only eta is maximum. Now therefore here for the option A, the ratio of the temperature of sink, let's say I tell it as 1 minus T2 by T1, where temperature of sink is T2, temperature of source is T1. So therefore for the option A, for which combination of working temperature of source and sink. So here it is told, option A is told temperature of source, that is T1, that is 600 Kelvin, and temperature of sink, that is 400 Kelvin. So therefore T2 by T1, that is 4 by 6, that is 2 by 3, which is approximately 0.6736, yeah. And for the option B, the ratio of T2 by T1, so T2 is given 200 and T1 is 400, so that is 1 by 2, that is 0.5. And for option C, T2 by T1, that is 300 Kelvin by 500 Kelvin, that is 3 by 5, which is 0.6. And in option D, it is T2 by T1 is for 100 by 300, that is 1 by 3, which is approximately 0.33. So in option D only, the ratio of temperature of sink and source is the least. So option D is the correct answer. Option D is the answer. Since why here only the ratio of temperatures of sink and source is minimum, so the efficiency eta is maximum here. Okay, then it is told, what is the source temperature of the Carnot engine required to get 70% efficiency? So it is given that the sink temperature is 27 degrees Celsius. So temperature of the sink, which is T2, that is 27 degrees Celsius. So we have to convert into the Kelvin scale, that is 300 Kelvin, since 27 plus 273. And temperature of source, what is the source temperature? T1, that is asked, to get 70% efficiency. So therefore efficiency is 70%. So that is 70 by 100, which is 0.7. So 0.7 is equal to 1 minus temperature of sink by temperature of source, 1 minus T2 by T1. So therefore we can say that 1 minus 300 by T1, that is equal to 0.7. So therefore 300 by T1, that is equal to 1 minus 0.7, which is 0.3. So T1 is 300 by 0.3. So T1 is 300 by 3 by 10, that is 3 into 10. So 300 is 300. Okay, so this is 1000 Kelvin. 1000 Kelvin is the temperature of the source. So in Celsius scale, T1 will be 1000 minus 273. So that is 727 degrees Celsius. So option C is the correct answer. Then question number 13 is a cycle tire bursts suddenly. A cycle tire bursts suddenly. What is the type of this process? So the cycle tire. So when the tire bursts suddenly, then it means that the volume of the air increases. Volume increases and the pressure. Okay, so here uh, so here since the time interval in this process is very small, so there is no so it means that it cannot be an isothermal process since the time interval required for um, for the temperature to remain constant, or for the isothermal process, uh, since the time interval required for an process isothermal process is large is large, so it cannot be an isothermal process. It can't be an isothermal process. So so it means that so it should be an adiabatic process since the time interval is very small, so the heat exchange is not there in between the system and the surroundings during this process. So it should be an adiabatic process only, since um, since there is no exchange of heat energy in between the system and the surroundings during the process. There is no exchange of heat between the system and the surroundings during the process. So it is an adiabatic process. So option D is the correct answer. Then in question number 14, it is told the efficiency of a Carnot engine which operates in between the two temperatures T1 equal to 500 Kelvin and T2 equal to 300 Kelvin. So 300 Kelvin is the temperature of the sink. So T2 should be obviously less than T1, since why the temperature of the sink should be obviously less than the temperature of the source. So therefore the efficiency eta of the Carnot engine would be 1 minus T2 by T1, that is 1 minus 300 by 500, that is 1 minus 3 by 5, that is 2 by 5, which is equal to 0.4. So 0.4 means it is 40%. So option B is the correct answer. Then in question number 15, it is told a Carnot's engine working in between 300 Kelvin and 400 Kelvin. It means the temperature of the source is 400 Kelvin and temperature of the sink is 300 Kelvin, has 800 joule of useful work. So it means that the energy output, we know that the energy output is actually the useful work done by the Carnot's engine. So that is equal to 800 joule. It is given here. The amount of heat energy that is supplied, that is delta Q, suppose. So delta Q is the amount of heat energy supplied to the Carnot's engine from the source. This is the source. So therefore the efficiency eta of the Carnot's engine, that is equal to 1 minus T2 by T1, and that is also equal to the useful work done divided by the heat energy that is supplied. So therefore here the useful work done is given as 800 joules. So that is 800 by, and this delta Q we have to find, which is the amount of heat energy supplied to the engine from the source. So 800 by delta Q, that is equal to 1 minus 300 by 400. So that is 1 minus 3 by 4, that is 1 by 4. So 800 by delta Q, that is equal to 1 by 4. So it means delta Q will be equal to 800 into 4, that is 3200 joule. So 3200 joule is the required amount of heat energy that is supplied to the engine from the source. So option B is the correct answer. And in question number 16 it is told the SI unit of specific heat capacity is SI unit of specific heat capacity. Specific heat capacity. So we know that delta Q equal to ms delta T. ms delta T. So S is equal to delta Q by m delta T. So it means that the unit of specific heat, so the unit of the specific heat S will be heat energy, that is joule, divided by mass of the substance. Mass of the substance, that is kg, so per kg, and divided by the temperature difference, that is Kelvin, so per Kelvin. So that is joule per kg per Kelvin. So option A is the correct answer. Then in question number 17, it is told that for which combination of working temperatures the efficiency of Carnot's engine is the least. So the efficiency eta of the Carnot's engine, that is equal to 1 minus T2 by T1, where T2 should be less than T1, since why temperature of the sink, that is less than the temperature of the source. And so I can say that efficiency eta is the least. Eta is least if the ratio T2 by T1 is maximum. If T2 by T1 is maximum. Now in the option A we have T2 is 20 Kelvin and T1 is 40 Kelvin. So therefore here T2 by T1, that will be equal to here 20 by 40, that is half, that is 0.5. And in option B it is, so T2 by T1, the ratio of T2 and T1 is 40 by 60, that is equal to 2 by 3. So that is equal to 3 6 18, 3 6 18, 3 7 21. So this is 0.67. And in option C, T2 by T1, that will be equal to 80 by 100. So that is 0.8. And in option D, that is 60 by, so T2 by T1, that is equal to, sorry, T2 by T1 here, that is equal to 60 by 80. So that is 2 3 are 6, 2 4 are 8. So that is 3 by 4, which is 0.75. So out of all these ratios of T2 by T1, in option C only, that the ratio T2 and T1 is maximum. So therefore in this case only the efficiency eta will be the least. So option C is the correct answer. Then in question number 18 it is told that a Carnot's engine takes 300 calories of heat from a source. So this is the source. It takes the heat which is delta Q, that is equal to 300 calories of heat from a source at 500 Kelvin. The source is at 500 Kelvin, means this is T1, and rejects 150 calories of heat to the sink. It rejects this much of heat to the sink. It means that therefore the amount of work done, that is equal to the amount of heat from the source, which is Q2, minus the heat which is being rejected, that is Q1. So let's say this is Q2, Q1 this is suppose. So Q1 minus Q2. Q2 is the amount of heat that is being rejected to the sink. Q2, that is equal to 150 calories. The temperature of the sink, that is being asked. Temperature of the sink, that is how much? So now therefore the efficiency eta of the Carnot's heat engine, that is 1 minus T2 by T1. So that is equal to the work done, the useful work done divided by the temperature which is supplied from the source, that is Q1. So therefore, and W is equal to Q1 minus Q2 by Q1, where Q2 is the amount of heat that is rejected to the sink. So therefore 1 minus T2, T2 is 1 minus T2, that is so this is so it means that 1 minus T2 by T1, that is equal to Q1 by Q1 minus Q2 by Q1. So Q1 by Q1, it is 1 here. So 1 and 1 will cancel, and minus will cancel. So from here we can see that T2 by T1, that is equal to Q2 by Q1. So therefore T2 by T1 is 500 Kelvin, and that is equal to Q2, which is 150 calorie, divided by Q1, which is 300 calorie. So calorie will cancel, 0 cancel, 15 2s are 30, so this is half. So T2 is 500 divided by 2, that is equal to 250 Kelvin. 250 Kelvin. So option B is the correct answer. So then here it is told a thermodynamic system undergoes a cyclic process ABC as shown in the diagram. The work done by the system per cycle is okay. So here from first it is a PV diagram, which is P versus V graph. So pressure is in Newton per meter square or Pascal, and the volume is in meter cube. So everything is given in SI unit. And from A to B there is the pressure is decreasing but the volume is constant, so it is an isochoric process from A to B. And here from B to C there is the pressure is constant but the volume is increasing, so it is an isobaric process. And from C to A it goes again from C to A. So first here from B to C the volume is increasing, and from C to A the volume is decreasing. So this is negative work done. This is from B to C there is positive work done, and from C to A there is negative work done. So from B to C the work done from B to C, that will be pressure, which is 100 Pascal into, so Pascal into meter cube, that is equal to joule actually. That is equal to joule. So this is 100 into P delta V. So it is 10 minus 5. So it is 500 joule. But from C to A there is negative work done since the volume decreases. Negative work done. So from the work done in C to A, that will be equal to area of the trapezium. So that will be half into sum of the parallel sides. Which is 100 plus 400 into height. Height is 5. So this is 500 by 2, that is 250 into 5, that is 1250 joule, 1250 joule, but which should be negative sign I should give. Now therefore the total work done by the system per cycle, therefore the total work done, that will be equal to minus 1250 plus 500. So this will be minus 750 joule. So option A is the correct answer. So then we shall solve the last question of our class on thermodynamics. It is told that in an adiabatic expansion of an ideal gas, the product of pressure and volume. In an adiabatic expansion of an ideal gas, the product of pressure and volume is not constant. So we know that P in an adiabatic expansion, PV whole power gamma, that is equal to constant. So therefore, now PV whole power gamma means it is 1 plus 2 by F, that is equal to constant K. So it means that P into V, that is then that into V power 2 by F, that is equal to constant. So it means that the product of pressure and volume is not constant. So, and when there is expansion, it means that PV, that is proportional to 1 by V power gamma minus 1. This we can say, which is 2 by F actually. So now therefore when volume increases, then V power gamma minus 1, that will also increase. So it means that 1 by V power gamma minus 1 will decrease. So it means that the product of pressure and volume will decrease when the volume increases. So in an adiabatic expansion, it means volume increases, the product of pressure and volume decreases. So therefore you can say that in an adiabatic expansion means that in an adiabatic expansion, the product of pressure and volume decreases. So it means that when there is adiabatic compression, it means that when the volume will decrease, then the product of pressure and volume will increase. So we can also say that in an adiabatic compression, the product of pressure and volume increases. So it means that here it is told about adiabatic expansion only, so the product will decrease. So option C is the correct answer. So hope you have understood the solutions of all these questions in this class on the previous year KCET questions on the chapter Thermodynamics. So please install our Sapience education application, since we shall upload some homework questions on every chapter, and those questions are based on previous year KCET exam, which will be helpful for your KCET. So here we shall end, and if you have any questions on any of the steps of the solution or any other doubts if you have, then also please write us in the comments section. So thank you everyone. Bye.